Awesome. Well, thank you everyone for being here. So yes, my name's Melina. I work on placoderm fish. I'm going to tell you a little bit about what that is in the next couple of slides. And I'm working mostly on the taxonomy, trying to resolve all the issues that we have with taxonomy, especially old taxonomy, and trying to do that using some modern methods, particularly phylogeny. So jumping right into it, so throughout the years, the number of species named is on a constant increase, of course, as illustrated here by this nice graph that we see from 2002, showing the increase in mammals in this case, and both living and fossil that were named since the 1850s. And among these, we can see that still quite, we can say too many turn out to be invalid for a variety of reasons. This is particularly notable for the older taxonomy for some groups. And this is mostly because, well, the naming was based on descriptive work, which is normal, but there was no phylogeny, no more techniques that we have nowadays, no morphometrics to help us assess things like ontogeny, and so on. Now, as we go, also just the lack of species, as we discover them through time. So as we make more discoveries and incorporate modern techniques, we can actually, reassess all of these taxa and then help us confirm or not the validity of both the taxa, but also the affinities among different clades. And in this talk, I'm going to illustrate this with the study of one specific placoderm I'm working on right now. It's in revision, the genus called Eastmanosteus. So I've mentioned placoderm twice now, so I'm just going to start with what in the world are placoderms. Well, placoderms are these guys right here, but also, most importantly, they're early vertebrates. They lived a long time ago. They're an extinct group, so they lived from the Silurian period, around 440-ish, a million years old, until about 360 at the end of the Devonian period. They were most abundant during this Devonian period here, called the Age of Fishes, because of their abundance in some of these fish groups, and also the emergence of new groups giving rise then to tetrapods, the bony fish. So there are about over 300 genera of placoderms. You can see the different groups here. So we have Enteriarchs, Acanthothoracids, Renanids, Petalictes, Arthrodires, Pictodonts, and these weird funky guys called the maxilla placoderms. So all these fall within the term placoderm. So there's quite a few clades among them. The main features they have include a skull and the thoracic armor, so the shoulder girdle, that is made of dermal bone, a bony armor, while the rest of the skeleton, so the post-thoracic skeleton, is made of cartilage that is lined with perichondral bone. So it's much more fragile and doesn't preserve well. So it's very rare to find these. Usually you just find some plates from the skull and the thoracic armor. But they are definitely key to understanding the origin as well as the early evolution and development of jawed vertebrate features, including particularly jaws and teeth, but also things like endochondral bone, so the bone that we have, and other weird things like internal fertilization, which is appearing here in placoderms, in some placoderm groups. And I focus specifically on arthrodires, which are the most diverse and common group of placoderms. But that being said, there's still a lot to learn about the intra and interclade affinities for a variety of reasons. We still find them, and again, taxonomy issues, lack of phylogenies in the past, etc. And we're going to jump right into the Eastmanosteus story. So it was first introduced in the 19th century, so it was some time ago, as a different genus called Dinichthyes. But it was quickly realized that Dinichthyes has so many species put into it that it became this, what we call a wastebasket. So there were many other genera actually included in this, which are not Dinichthyes, including, for example, Dunkleosteus and our little guy, Eastmanosteus, which was then renamed half a century later. And following the erection of that new genus, we have a lot more different ones added into it. So we're starting to have a similar questioning about whether or not Eastmanosteus is a valid taxon, as in, is it monophyletic? Is it all Eastmanosteus, or is it different things? And so following that, in 87, Dennis Bryan described a new species of Eastmanosteus from Australia and took advantage of this to also reassess the affiliation of each one of these taxa, and find out that many of them cannot be assigned to the taxon simply because for most of them there's not enough material to say with certainty. Following this, we've had two new species emerging, one both in the 90s, one from China and one from Manitoba, which is the one I've been working on here. But there's still been suggestions the suggestions remain that they still may not be monophyletic. And that's simply because the definition of the genus has never changed. So it's a very poor and very broad definition. And also we have poorly known taxa still in the mix. For example, the Chinese one is only known by one or two plates. So just to show you a little bit, I'm not going to describe the skulls or anything of the animals, but this is the holotype of Eastmanosteus lundarensis, which was found here in Manitoba, next to Lake Manitoba. And you can see it here on the map on the left. And we found specimens in 4 different quarries. So you have the skull here from dorsal view, but I'm giving you a line drawing, so it's a little easier. So we have the different plates. I'm showing on, hopefully you can see it. Let's see, pointer. So here you go. So this right here, that curve you see on each side, not very preserved well on the left side, corresponds to this here, and that's where the orbit fits. That's the top of the orbit, so in dorsal view, remember. And then we have also, notably here in the back, the double articulation with the thoracic column from the back of the skull. So instead of having one condyle, they had 2 articulations for the up and down movement. Now, what we did with this guy, well, first we redescribed it based on some new specimens and the old ones, and we also assessed intraspecific variation, which I'm not going to discuss here because not enough time. And then we just placed all this in a phylogenetic context. We included the best known taxa of the genus Eastmanosteus, and we ran that through both parsimony and Bayesian, 2 types of phylogenies. These are the different best known species within Eastmanosteus at the moment, which are the ones we included in the phylogeny. This one is from the Magnificus is from the US, Calliaspis is the Australian one, and Pristolosus is another one from the US. All of them are a little bit younger in age from the late Devonian compared to ours, which is the middle Devonian, so a little older. We put this in our beautiful matrix right here. It looks very messy, but it's organized, kind of. And the results of the phylogeny here is, well, we end up finding out that in the Bayesian, which is a more mathematical based one, is much more programming involved in this one. We have 2 of them plotted here, not together, and other Eastmanosteus plotted here, not together. So we have here what we call a polyphyletic group. So I just put a reminder here of the different types. So pariophily, monophily, and polyphily. So we're starting to have this, oh no, we're dealing with a wastebasket taxon again in this one. And then we tried the parsimony, and parsimony, even though they plot in the same branch, which is what we've had in the past, they still don't plot all together. They're quite spread out within the tree. So we still have the same thing. So I'm putting a zoomed version here of the different groups. So we have the same issue. We still have this strong support for polyphily or wastebasket type grouping of Eastmanosteus. And we also did some probability testing within the Bayesian, which you can do with my co-author, and well, the support again for monophily is very poor, which basically just means the genus is made of multiple genera and needs to have much more extensive reassessment onto it. So we just did that one now with Eastmanosteus lundarensis, the Manitoban one, and there will be a future one coming up with a Australian study coming from a colleague of mine, and is more to be done with all the different species in there. So just summarizing things a little bit, we have what I didn't talk about too much, this whole description of our little guy, as well as some discussion of each of what we feel about the affinity of each of these animals, species within the group. I didn't need to go into too much detail because it's very specific. But we did identify some intraspecific variation, which is pretty nice because it's often kind of missed or not really discussed in many papers. We don't have any ontogenetic series to our knowledge that we can see, at least. We were able to describe the ventral view and as well as the jaw elements, which we didn't have before. We have a nice little partial lower jaw of the animal. And as I've mentioned regarding the phylogeny, we have a strong support for, not monophily, polyphily, like in the title, sorry about that, of the genus Eastmanosteus, in both methods, Bayesian and parsimony. which kind of means that we basically have another wastebasket taxon, unfortunately. And as I mentioned, there's a lot more revisions coming, and that will need to be made to reassess all this with more accuracy. And with all that in mind, thank you for the conference team. Thank you for the members and all my co-authors and collaborators. I'm happy to answer any questions that you guys may have, however specific they may be.